All right, so this is going to be 34-1, and let's go ahead and go through the questions here. So on the first one, it says graph one cycle of the given function, state the domain and range. So for number one, I said the important values or the important things that we need to know so far is first, we need to know the parent graph. Well, the parent graph is a sine graph. Well, sine looks like this. So that's kind of like what the sine graph is. Now, from that parent graph, I have to know what the important values are. And so I know that the standard amplitude is obviously 1, so the distance there is 1. And then these values, that's going to be 0, that's going to be pi halves, that's going to be pi, that's going to be 3 pi halves, and that's going to be 2 pi. Now remember, I said that those values can change, but for right now, we just need to focus on what those values are or what they're going to be. And then any other information about this graph, the amplitude, because it says y equals 3 sine of x, I know that my amplitude is going to be 3. So now graphing this, these values is 0, pi halves, pi, 3 pi halves, and 2 pi. The amplitude we said is 3. Okay, that's how high or low it's going to go. And so now drawing the parent graph, there's my sine graph. Now I knew I drew dots here, like those dots aren't supposed to be there. I kind of just, it was kind of like helping me to see how high and how low it's going to go. Now it's asking us for the domain and range. The domain of my function, this is technically going to go on forever that way. This is technically going to go on forever that way. That's going to be negative infinity to positive infinity. And my range, the lowest value is here, which is at negative 3. And the highest value is here, which is going to be positive 3. For number 3, y equals negative tangent of x. Now, for tangent, remember there's no amplitude. Doesn't exist. Remember that. With tangent, there is no amplitude. Now for the parent graph of tangent, we said that Dad is going to help us graph this. Dot, asymptote, dot. And the graph is going to do something like that. That is one cycle of my tangent function. And these important values that I said that we need to memorize, this is going to be 0, this is going to be pi halves, and this is going to be pi as we move along that x-axis. And so now, graphing this function, there's a negative. So a negative means reflection about the x-axis when it's in front of your function like that. So this is going to get reflected down, this is going to get reflected up, and so my graph is now going to be, if I were to label it, here's 0, here's pi halves, here's pi, and so my graph, we have an asymptote here still. My graph is now going to go down, and that one's now going to go up. And so that is one cycle of my function. All right, going over number 5. We have negative infinity to 4, intersection from 5 to 8. So from negative infinity to 4, so we'll say here's 4, closed circle. How does that intersect with 5 to 8? Well, here's 5, closed circle, and all the way to 8, open circle. And so because it's asking for the intersection, it's saying where do these overlap? Well, they don't overlap at all. So empty set, or nothing, no solution, no value. So they don't overlap at all, so therefore there's no solution. Let's see, let's try for find the x and y intercepts and test for symmetry. Number 7. I have y equals x to the third minus x. So to find the y-intercept, I set x equal to 0. So y equals 0. So therefore my point is going to be 0, 0, because if I plug in 0, 0 cubed minus 0 is 0. For the x-intercept, I have to plug in 0 for y. Now I need to solve for x, and so it looks like I might have to do some factoring here. So I have 0 equals x cubed minus x. I factor out an x, so 1, and then that's a difference of squares. So that means my values for x, since they all equal 0, x is going to equal 0, -1, and +1. So then my x-intercepts, list them as points, those are going to be 0, 0, -1, 0, and 1, 0. Now testing for symmetry, hopefully I have a room. If I wanted to test over the y-axis, we have to plug in a negative for my x and see if it's the same. So if I do that, this is just going to give me that turns negative, that turns positive. Nope, those are not the same as the original. If you notice, this y equals -x cubed plus x is not the same as the original, so therefore it is not symmetric over the y-axis. So now we can try the x-axis. That means I take all of my y's and I replace it with -y. So then I get -y equals x cubed minus x. Are those the same? So this is not the same as this, so it's not symmetric over the x-axis. Now we have to try the origin. That means a negative with both of them. Now even if let's say if I factor out a negative here, so -y, -x cubed minus x, well the negatives cancel out, so now I get y equals x cubed minus x, which is now the same, so yes, it will be symmetric about the origin. Number 9, it says describe if it's going to be a function. Well, if you look at this, because it's going to fail the vertical line test here, right, the points overlap, it's not a function. And then writing the domain, I get -4, -3, -2, -1, 0, and 1. Now I'm listing them as individual points because notice there's no graph in between. So I have to list it as -4, -3, -2, -1, 0, and 1 because there's nothing in between. Now if it was like a line, then I would have to write in like an interval to say it's all the values in between those. And then for the range, listing them as a set, -1, I have 0, +1, 2, 3, and 4. And so there's my range.